We're going to solve several equations that have logarithms, and one of the big picture strategies for solving equations with logarithms, as soon as you get a single log by itself, then you want to change to exponential form. All right, so let's do that. Silly way to remember it here is I call the base the beaver. And so this beaver is going to tunnel under and the log falls in. So if I have this 10 tunnel under and the log falls in, the only thing left on the left side is x. I have equals. The 10 comes up underneath the 3 and pushes that up. So this is 10 to the third power. 10 times 10 times 10 is 1,000, and we have that one solved. All right, so leave it to beaver. We're gonna have the 64 tunnel under. So if 64 tunnels under, the only thing left on this side is x. We have equals, and then the 64 comes up underneath the 1/2. So this is 64 to the power of 1/2. A quick reminder of evaluating. When you have an exponent that's a fraction, it is a root. So I have the root of 64. Now where do these numbers go? Inside, outside. The numerator goes on the inside and the denominator goes on the outside. So this is 64 to the first power, and then I have the square root, which of course is 8. Let's take a look at a few other ones. We're going to use a rule that if you have a to the m equals a to the n, then the exponents are equal to each other. I'm going to start off by tunneling under and changing this to exponential form here. So the x tunneled under, I have 1/64 equals x to the power of -3. To use this property, I really want a power equals a power. Now on the right-hand side, that one is all set, x to the -3. But the question is, how am I going to rewrite 1/64? 64, thinking about an exponent of 3, 64 is 4 times 4 times 4. Knowing those are going to be -3, this is 4 to the power of -3. That makes it 1/4 to the third, and then we had our 1/64. Now that I have rewritten it so that the exponents are the same, I now know that x must be the number 4. Okay, let's try that again. The x tunnels under, and when the x tunnels under, I'm left with 1/100 on this side. The x comes up underneath the 2, so x to the second power. We're utilizing the property that we want to get two powers set equal to each other. This one is x squared, so I need to figure out how to rewrite 1/100 as some number to the second power. So thinking of what would that be to the second power? Well, 1/10 multiplied by 1/10 is 1/100. So that's going to be 1/10. So if 1/10 squared is equal to x to the second power, then 1/10 is equal to x. So this is just a quick reminder here. So I made 1/64, thinking of that as 1/4 to the third, and then 1/4 to the third is 4 to the -3. For this one, the 1/100, I'm thinking of that as 1/10 squared, but that is the same thing as 1/10 times 1/10 gets me back to 1/100.